Page 95 of the notes. According to a survey in a particular country, 28% of adults do not own a cell phone. Suppose a simple random sample of 200 adults is attained. So they had to use a survey to get kind of the p-value. So this in itself is a p-hat, but then they want you to take another survey. So either way, where you're going to use the formula, but it's almost like we're going to center everything around 28% because that's our original guess for the percentage of people who do not own a cell phone. So it says, is the sampling distribution normal and why? And according to the notes from before, we have to check our RIN conditions, which would be random, independent, and normal. So the first question is the sample random? And we're going to assume it is based off of the fact that they said it's a simple random sample. The next is independent. So when you draw a person out of the population, is it independent of drawing the next person? And we talked about that in class when I draw a stick out of my can. If I draw out a boy and put it back, and then I find the probability of drawing another boy, that's independent. But if I draw out a boy and don't pull it back, put it back, and then draw another boy, that would change the probability of getting the second boy, and so it would be dependent. However, if you had so many sticks in there and you only draw a small sample, the change would be so tiny it wouldn't matter. So we have a rule that says as long as your sample size is less than 5% of the population, you can assume independence. So assume each person in the sample is independent of each other, and the way you prove that is you really assume n equals 200. Actually, let's do it this way. Assume the population is greater than or equal to, and we want to figure out what the population would have to be, so 200 would be 5% or less. So we would do, clear please, 200 divided by 0.05. And we would have to have at least 4,000 people in the population, which I'm assuming you would in a particular country. So assume the population is greater than or equal to 4,000 would make sure that a sample of 200 was less than 5% of that population. So you always just take n and divide it by 0.05. All right, lastly is the true normality condition, which we're going to look at by flipping coins. You'll do the flipping coins today in class, and then we'll discuss it next time. And so what we say is n times p greater than 10? And in this case, 200 times 0.28 is 56, which is greater than 10. And then we want to look at n times 1 minus p, which we can also call n times q. But anyway, that would be 200 times 0.72, which is 144, which is also greater than 10. So we've checked our RIN conditions. It's a random sample. The population is at least 4,000 by assumption. So our sample's small enough to be considering the sample, to make the sample considered independent. And the normality condition holds. So yes, we can consider it normal. And now that allows us to find probabilities, just like we did before. So what is the probability that in a random sample of 200 adults, more than 30% do not own a cell phone? So you could do this in a couple of ways, but the best is to work with the percents. And so here's our picture, right? We're assuming the actual value is 28, and we're going to find the probability of more than 30%. And so we're going to use GeoGebra. But before we do that, we have the mean, we need the standard deviation, and in this case, it will actually be the standard error because we're basing it off of the guess of 28% as the mean. And so we're going to use the formula of p times 1 minus p divided by 200. And if you put that in your calculator, you get a standard deviation by about 3%. Okay, and we would use GeoGebra to find this. or in other words, to find the probability of getting another sample of greater than 30%. So I'm going to jump to GeoGebra, and we want greater than, so we're going to use this button. And we say that the mean is 0.28, and the standard deviation, you're welcome just to type in 0.03175, go out a few decimals, or you could type in the square root there, which is what they show you to be more accurate. Just go out several decimals if you don't want to type in the square root, it's up to you. And we want the probability of x being greater than or equal to 0.30. And so it turns out that is a 0.2644 probability, or 26.44%. So to answer my question, this is about 26% of the curve. The probability of taking a sample of 200 adults out of this population and getting 30% or more who do not own a cell phone, given that the true value is 28%, is 26. So the chance of getting a little bit of a high sample, 30% or higher, is 20%, 26%. So I would say if 100 random samples of 200 adults were obtained, one would then expect about 26 to result in more than 30% not owning a cell phone, because 26 is 26% of 100. Let's do a couple more. What is the probability that in a random sample of 200 adults between 25 and 30 do not own a cell phone? So again, oops, I lost part of my picture. Again, you have your picture. Go to GeoGebra. I'm just going to keep the standard deviation and the mean in there. And this time I want the middle part. And I want it between 0.25 and 30. And I'm assuming my GeoGebra is working correctly. If it's not, you might get something different. Notice that sometimes it's picky. But we are going to say the answer to that is 0.5633. And so the probability of getting a p-hat between 25% and 30% is about 56 1/3%. All right, would it be unusual for a random sample of 200 adults in this particular country to result in 50 or fewer who do not own a cell phone? Why? Well, there are two ways to think about this. Let's first look at the picture. We want 50 or fewer. So what is 50 or fewer when we're talking about a sample of 200? So we need to figure out what that p-hat or sample proportion would be. So 50 divided by 200, this is the specific sample we're worried about, would be 25%. So of having a proportion of 25% of the people not having a cell phone, or maybe less than that. And so you could do it by figuring out how many standard deviations below the center this is, or by finding the probability. So let's first find the probability. I'm going to go over here. Goodness gracious, there we go. And this time I want it less than 0.25, and I get 17%. So this is 17% of the curve. Again, you can see here that. So the probability is 17%. Is 17% less than 5%? No, so we don't consider it rare. Or we could find the z-score to tell us how many standard deviations below average it is, which would mean if this is 0, because this is average, we could plug what we get, what we're looking at, 25%, minus the average, divided by the standard error, which is what we're using as a measure of spread or standard deviation. And it's only negative 0.94 standard deviations below average. It's not that low. So again, it's not rare. less than 2 standard deviations away is rare, 3 standard deviations is very rare. So both of these show that no, not rare. And that's it. Thank you.